One big thing to keep in mind is even though you might not see it and that rotor starts to wear, it's going to decrease in diameter, so your compression is going to be lower even with a brand new stator. So your stators will start to not last as long if you neglect to replace that rotor.
Hello and welcome to the Pumps and Systems podcast. I am your host, Tom Baer, a managing editor at Pumps and Systems magazine. Today we're speaking with Westyn Bennington from SEEPEX, who's going to be telling us all about maintenance technologies, specifically as they relate to progressive cavity pumps. So without any further ado, let's get into the episode. So welcome to the Pumps and Systems podcast. We really appreciate you being here. So how are you doing today?
Thank you. Yeah, I'm doing great. Been a busy start to the year, but it's going well. How about
Glad to
yourself?
hear it. Oh my, no one's ever asked me the same question before. I'm doing well, thank you. Okay, so before we get started on our main topic, would you mind introducing yourself? So tell us a little about who you are, what you do, anything you'd like our listeners and viewers to know.
Yeah, so my name is Westyn Bennington. I'm a product manager with SEEPEX Inc. I've been with SEEPEX a little over 4 years now. Started off as an applications engineer, so was quoting pumps, working with customers on new projects, and then just over 2 years ago, I switched into the product management role. That's been really rewarding because I get to work on new product development and help support our existing product lines. So.
Sounds good. Okay. All right. So today we're going to be talking about maintenance technologies, specifically for progressive cavity pumps. So first of all, let's talk about the absolute basics. So what is a progressive cavity pump, and what are some of the typical maintenance items for that kind of pump?
So a progressive cavity pump is a rotary positive displacement pump. So the main elements are the rotor and stator. So the rotor's typically metal. It's shaped kind of like a corkscrew, and then it rides inside an elastomer stator. And there's actually a compression fit in between the rotor and stator. And as the rotor spins, it creates a cavity that progresses from the suction side to the discharge side of the pump. So that's kind of the main pumping action. It's connected to the drive, the motor and gearbox via a coupling rod, and there's typically two joints, and then of course a single seal that seals the shaft and coming into the pump. Biggest maintenance item with a progressive cavity pump is the stator. So that's what's going to be replaced most frequently. As I mentioned, it's an elastomer or rubber. So as the pump is rotating, that rotor is kind of sliding against the stator surface, and eventually over time that rubber starts to wear away, and you'll eventually get some slip. So product will move past that sealing line in between the rotor and stator, and as that effect starts to get worse, typically that's you'll notice a drop in flow rate, and customers will typically replace the stator then. The second most common wear item is the rotor. So even though it's metal, it actually still does wear. There's some things that manufacturers do to help prevent that wear. Chrome coatings and platings, or special materials, hardened materials, are used to help prevent the wear on the rotor. But eventually you will see some wear. Typically we see customer will replace the stator 2 times, and then on that second time they're replacing it, they'll also replace the rotor. One big thing to keep in mind is even though you might not see it and that rotor starts to wear, it's going to decrease in diameter, so your compression is going to be lower even with a brand new stator. So your stators will start to not last as long if you neglect to replace that rotor. So those are the two main wear components. Some secondary wear components that you might see are the joints. So over time, especially if you have a lot of starts and stops, because of that compression fit, it takes a lot of torque to get that rotor spinning. So if you have a lot of starts and stops in your process, eventually the joints can start to wear. and those may eventually need replaced. But typically, those are a much longer cycle than the rotors and stators. And then lastly, the seal is another potential wear item. Similar to the joints, over time there's some vibrations, and as the joints start to wear out, you can actually get some run out in the seal area. So that shaft can have some radial movement, some end play, and the seals can eventually wear out as well. Also with solids and things like that, could potentially wear them. But again, those are typically replaced at in much longer intervals.
All right. So then what are some challenges you might face if you were replacing or repairing these kinds of pumps?
One of the biggest complaints that we hear is actually trying to get the stator off of the rotor. So think of, you open up a bottle of wine and you're trying to get the cork off the corkscrew. Sometimes it can be kind of difficult. As the pumps get bigger, that becomes more of a challenge. The other thing to keep in mind too is on a traditional progressive cavity pump, you have to pull that rotor or the stator off of the end of the rotor. So you need to account for that in your piping setup by putting like a spool piece in that you can remove. That's one of the challenges that you see with maintenance. Typically, the way to overcome that is to either pull the pump out of place, where you can get it into a workshop area where it's easier to put a winch or some sort of other mechanical device to pull that stator off. That's one of the challenges. Some of the other challenges are just accessing some of the components. If the pump is in a in the equipment mounted somewhere where it's difficult to access, that can be a challenge as well with a traditional pump.
So what about if you have a requirement for a very small footprint? What are some steps that you might take to address that?
So some of the footprint requirements that we see, sometimes we're replacing a pump. It could be a different technology, and progressive cavity pumps are fairly long, right? So the rotor and stator actually get longer the higher pressure the application is. So sometimes fitting them can be a challenge. We have a couple ways that we can reduce those space requirements. So one, we can use a right angle drive or a helical bevel drive. It's sometimes called. That is a gearbox basically that is mounted at a right angle instead of in line. We typically use gearboxes with progressive cavity pumps because the operating speeds are, anywhere from 100 to 400 RPM. We try and keep them pretty slow, and typically, your standard four-pole motor is going to be 1800 RPM. So you need some gear reduction there. So the right angle drives will reduce the total length of the pump. We can also do what we call a piggyback design, which is where the motor is actually mounted above the pump, and then you use belts and pulleys to achieve some speed reduction. So that's another option as well to reduce the size, or that motor can be mounted on either side of the pump as well. That adds some additional maintenance challenges, though. Over time, the belt will start to stretch. So the motor is typically mounted on some sort of adjustable stand. That way you can raise it to retension that belt. So we typically prefer the helical bevel gearboxes instead of the belts and pulleys, just because it's a little bit less maintenance on that side. For maintaining some of the other parts I mentioned earlier, you need that additional space to remove the stator typically. That's where we see pumps that are considered maintain in place. So that's one of the biggest challenges that we've seen in the progressive cavity pump industry is customers aren't used to having to remove a pump from the pipe work, or have that spool piece. And so that was a challenge that pump manufacturers were tasked to address, and that's where the maintain in place pumps come along. And essentially, what a maintain in place pump is the manufacturers have modified typically the suction housing of the pump to where you can open that up, whether it's sliding or split axially, to where you can access the either the coupling rod or the rotor head, and you can actually detach the rotor and stator and pull it out as a cartridge without having to dismantle the discharge piping. And then you can bring that cartridge into a workshop and work on it from there.
That sounds a lot easier than taking the whole thing apart.
Yeah, it makes the whole process easier. It can shorten the maintenance times as well, and that's especially important if there's no backup and every minute that the customer is down, they're losing production, which is valuable, right? So being able to save some time and make that process easier is generally well received.
So now let's talk about maintenance technology in general. So what sort of maintenance features are available in that technology right now?
So I mentioned before the split housing or the sliding housing. So different manufacturers do it differently, but almost all of them are going to include some sort of suction housing that you can open up because within the suction housing that contains the joints that I talked about. There's a lot of different joint technologies on the market as well. Pin joints are probably the most common, which are relatively easy to work on. Hardened joints and gear joints are also common in the market. They have some additional parts, so a little bit more difficult to work on those. But being able to open up that housing provides you access to those joints, so you can dismantle them, and that's really the only way you're going to be able to take the rotor and stator off in a traditional pump. But what some manufacturers have added to help make that process easier, because you're not always really needing to replace the joints every time you do maintenance on the rotor and stator, they will include some sort of detachable point in that rotating assembly. So it's done in two different ways. One is the middle of the coupling rod or connecting rod. That's the rod that's in between the two universal joints. A lot of manufacturers will split that rod with like a stair step pattern or something to where you can unbolt that and then remove the rotor and stator together, and then the rotor sided universal joint is still connected because you're splitting that rod in the middle. There is another design where actually you have the connection point in front of that joint, so you can actually replace the rotor without having to rebuild that joint. So that design we see is typically preferred, just because you don't have to rebuild any joints unless the joints actually need maintenance. So you can replace the rotor without having to take the joint sleeve off and repair all those parts inside.
So next, let's talk about open hopper pumps. So first of all, what is that? What are open hopper pumps? And what do you do with open hopper pumps that are mounted to dewatering equipment or under silos?
Some time ago we saw a need in the market for the ability to pump high viscosity materials, materials with really high solids contents, and the progressive cavity pump is pretty well suited for that. So, as I mentioned, the product flows into those cavities and it moves it forward. The pump doesn't really care what's in those cavities. If you can put something in there, it's going to move it from the suction side to the discharge side. As long as it has a little bit of liquid in there to keep that sealing line cool and prevent the pump from running dry, it will handle it. So there were some designs. There's many different designs out there depending on the application, but essentially with an open hopper pump, you take the suction housing of the pump and make it just a large hopper, and the coupling rod or connecting rod that I talked about earlier, that has an addition of an auger on it, and the auger will feed product into those cavities. There's many different auger designs depending, like I said, on the application. As you get to higher solids, some manufacturers will use bridge breakers. So the product when it's very thick or really high solids content, it can tend to bridge. So basically, the auger will cut a hole through the product essentially, and it'll just sit there like a bridge. And so the bridge breakers, some paddle shafts or something like that, that try to knock that product down. There's also ribbon augers that have a similar effect. It's shaped like a ribbon that encapsulates the coupling rod that will help with some of those things. But essentially, all you're trying to do is overfeed the cavity. That way, you can stuff that material in. And obviously, typically is a bigger size pump. And so there's probably a couple other maintenance items that you might need to worry about over the lifetime of the pump. And as you mentioned, they're also typically mounted under some sort of dewatering equipment. So a lot of times these are handling waste, particularly at municipal wastewater treatment plants, dewatered sludge. They can also be handling spent grains from breweries and distilleries, those types of things. And typically, when people are trying to dispose of a waste, they try and remove as much water as possible, so they only have the solid waste to dispose of, and reducing the overall disposal costs. So as they're mounted under these equipment, maybe they're mounted under a silo, or there's some sort of extension hopper that is mounted directly to the equipment to keep everything enclosed. You don't have access to the hopper anymore. So if you do need to access any of those joints, it can be quite a challenge. So there's a few ways that companies have innovated to make this process easier. One of the earliest ways was basically just to mount the pump on a base plate that had some wheels to where it could be lifted up or actually lowered with leveling feet onto those wheels, unbolted from the equipment, and then slid out of place so it could be maintained, in a workshop or something like that. Just make it easier to move. So some more recent advancements that we've seen are the at the front of the hopper. There's typically a part that we call like a compression zone or a stuffing zone, and that zone is a cylindrical shaped portion of the hopper where the auger is overfeeding or stuffing the product into, and that's right before the product enters those cavities. And that zone can be actually detachable from the hopper and slid forward over the stator. And then you can access that rotor sided universal joint there and take that joint apart, so you can remove the rotor and stator as a cartridge. So that's one of the advancements. The other advancement is on the drive side, so the side where the motor and the gearbox are. There's also an option to basically make a similar cylindrical housing on that side and slide it back towards the drive again to be able to access that side of the joint, towards the drive side, so you can do maintenance there. If there's other augers or things like that that are attached on that side, you can unbolt those and do maintenance on that side as well.
So what are some of the cost benefits to using these kinds of maintenance technologies?
So the cost benefits are really just in the time savings. So that's probably the major component, time savings, and also the downtime. If you can reduce any downtime, like I said before, anytime a plant is not producing product, they're typically losing money. So if you can reduce the amount of time that a maintenance task takes, that can really help save money on that side, as well as just if you can free up some time from the maintenance staff, they can work on other equipment, right? So that's a big cost savings. And then of course, there's some other cost savings available with some of the maintenance technologies, right? Like you're not rebuilding the joint every time on some of the designs, so you can save some money on the joint parts. There's even some stator technologies that help reduce some of the cost as well. From a few different manufacturers, there's stators that aren't actually bonded into a metal tube. So normally they're molded inside just a hollow metal tube, and so when the stator wears out, you have to throw away that metal tube and the remaining rubber inside. So more weight, more volume, right? Some manufacturers offer a stator that just the rubber is there. It's not bonded to the metal tube. The tube can either be, pulled off and saved for the next time, and just the rubber piece can be disposed of and replaced. And then there's also split stator designs where the stator can be removed in two pieces And then that also gives the advantage, typically, of being able to readjust and actually reestablish some of that compression that the pump was originally supplied with. So if you can tighten those two, say the two halves down, you can reestablish that compression and reestablish your performance as new. So that saves some money by extending the life of the stator as well.
So, next, let's talk about what people should be looking for when it comes to maintenance technology. So, what kind of language should they put in their specifications if they want this sort of design?
So, when writing specifications, if you're working with an engineer, maintain in place is the industry language that you would see from pretty much all manufacturers of progressive cavity pumps. So that's something to put in there, to look out for. You can also put specific language in, as far as what type of design that you want for the detachable rotor assembly. So if you want it in the middle of the coupling rod, or towards the rotor side, so you don't have to replace the joint. And then you can also specify the type of stator technology that you would like. As I mentioned, if you want the stator to be able to replace without the being bonded into the tube, you just want to be able to replace the rubber part. That's something that you could include in specifications as well. But most manufacturers are going to have their own specific language. You can always reach out to them. But knowing what you want and putting that in the specifications is always best. That way it's clear to everybody who's designing and working on the project, what type of technology you need for your application.
All right, so before we wrap up, is there anything else you'd like to share or any final thoughts you'd like to leave us with?
I can't think of anything. I just really appreciate the time. It's always fun nerding out about progressive cavity pumps. So I hope it was interesting for you.
Absolutely. I mean, I definitely learned some stuff, and I have not had an opportunity to nerd out about progressive cavity pumps before, so I appreciate the opportunity.
Awesome.
Huge thanks to Westyn for taking the time to speak with us today about maintenance technologies. If you're listening to the podcast and would like the chance to watch it, head over to our YouTube page to see the full video version. That's going to do it for this episode. Thank you so much for listening or watching, and we will see you next time.